This is a video on solving a system of linear equations by substitution. If you haven't already seen the video on how to solve a system of linear equations by graphing, watch that one first. Otherwise, feel free to pause this video to take notes, or if you need more time to process the information, let's get started. Okay, as you can see, I've got the exact same problem up on the board as I did from the last video. And the question is, well, if we've already been able to solve it that way, why do we need other methods for solving it? And that's because some methods have weaknesses. And, well, every method has its strengths and weaknesses, okay? In some situations, it's more advantageous to use substitution. In others, it's going to be graphing. And even further on down, it might even be better to do it by something called elimination, which is the next method that we're going to be working on. So why not do it by graphing? Well, graphing takes up a lot of space, it takes time to graph things, and it's highly dependent on how accurate you can make your graph. And if you don't make your graph that accurate, or if, for example, you have a grid and the lines that intersect happen to intersect in a location like in the middle of the box that's not very convenient to read or to interpret, then it's difficult to figure out what the exact solution might be to a system of linear equations. Ours happen to intersect at a point, but not all systems of linear equations will do that. So we need to find a different method that will make us a little bit more confident about our answers. Okay, so we've got 2x minus 3y equals 18, x plus y equals 4. All right, so what can we do here? Well, I know that x and y have the same value no matter which equation we're talking about. We know they're going to intersect. We know they have to share that same value. Whatever this is for x, that's the same x. Whatever this is for y, that's the same y. It's just that this shows two different relationships between x and y. This tells me what happens if I add the two numbers together, and this is telling me more or less what happens when I subtract the two numbers from one another. Okay? Two different relationships, but those two different relationships between those numbers give me an idea of what those two numbers might be. So I can use that to my advantage and do something called substitution. But in order to do substitution, you have to manipulate one of your equations. So in general, I'm going to manipulate one equation, and I'm going to plug it into the other equation that I did not manipulate. So here, the equation that I'm going to manipulate is the bottom one. And that's because it looks easier. There's less numbers involved. There's no negative sign. So it looks a lot easier to manipulate. And really, it doesn't matter which one you manipulate. You can manipulate the top. You can manipulate the bottom. Again, it doesn't matter. I just choose to do the bottom one because it looks easier. When I manipulate the bottom, I have a choice. Should I manipulate it to solve for x or to solve for y? And again, it doesn't matter. Choose one, x or y. Most people feel comfortable solving for y because we always tend to take linear equations and solve it in terms of y, or for y, because we like the y equals mx plus b look, the slope-intercept form. So I'm just going to follow in that fashion. If I manipulate this equation, I'm going to get y is equal to negative x plus 4. There's my manipulation. Where does the substitution come in? Well, the substitution comes in when I plug this into the other equation, which I haven't manipulated. Remember, you only manipulate one, but not the other. So let's do that. I've got 2x minus 3 times y equals 18. And you'll notice that I put parentheses where y originally went. Here's y in my original equation. 2x minus 3y equals 18. It's the same thing, but I put parentheses where the y is. Why do you think I do that? It's because I'm going to substitute. Hence the name of the method, substitution. So instead of putting y here, I know from the other equation that I manipulated that y is the same thing as saying negative x plus 4. So I'm going to plug that in to this equation, negative x plus 4. Now I can solve for x, because I've got one equation with one unknown. So I'm going to go ahead and simplify this. I've got 2x. This is a minus 3 times this entire quantity. So when I do a distributive property to simplify this, be sure that you're including the negative with the 3. So this is negative 3 times negative x. That's a positive 3x. This is a negative 3 times a positive 4. That is a negative 12. And that equals 18. I can combine like terms. I'll end up with 5x minus 12 is equal to 18. If I add 12 to both sides and divide both sides by 5, I get x is equal to 6. All right, now I know what x is. How do I figure out y? Well, x is going to equal 6 no matter which equation I used. It's got to be x equals 6 for the top equation, and it's got to be x equals 6 for the bottom equation. I'm going to go ahead and pop it into the bottom equation, since it really doesn't matter, because the value for y has to be the same for both equations as well. I don't want to put it into this one, because if I plug x equals 6 into this one, then I have to solve for y again. Well, why don't I just pop it into this one? I guess it doesn't matter, but since I'm going to end up solving for y anyway, I might as well just plug it back into this equation. Really, it doesn't matter where you plug x back in. As long as there's an x and y in the equation, you're going to end up solving for the y in that equation. Make sense? All right, so what I just said, in an even longer version, if I take x equals 6 and I pop it into this equation, I'll have some number minus 3y equals 18. I have to solve for y. If I plug in x equals 6 into this equation, I will have 6 plus y equals 4. I have to solve for y. But if I plug it into this equation, because I already manipulated it for y, whatever this simplifies out to be, that'll be my answer. So let's pop it in there. I've got y is equal to negative, and the number I'm putting in for x is 6 plus 4. And when I simplify that, I will get y is equal to negative 2. And you'll notice that it's the exact same answer as we got from the last video for the exact same problem. We're just using a different method. Okay, that's it.